Hi everyone. This is Pure Maths and we're looking at graphs and transformations. We've done a lot of graph sketching. We've sketched few graphs. We are now going to look at how we can be able to transform these graphs, or we can be able to transform equations that represent these graphs. But before we do that, there are some graphs here I've drawn. This is for your attention. Graphs like this, you should be able to identify them the moment you spot the function. It should come to your mind how the graph looks like. It helps a lot solving problems in graph transformations. If y is equals to 1 over x, the graph looks like this. It takes this form. If the function y equals 1 over x, the graph will look like this. This is approaching to infinity on the y-axis, approaching to infinity on the x-axis, on the positive side as well as on the negative side of both axes. If y now is 1 over minus, is y equals 1 minus 1 over x, this is how the graph will look like. It's a good practice to be able to have the picture of these functions, or the picture of the graphs of these functions in your mind. It helps when you are solving plotting graphs. This is a quadratic function. When y is x squared, you get this type of graph. You should be familiar with this. And when it is 1 over x squared, the graph looks like this. If it is minus 1 over x squared, the graph looks like this. And this is a cubic function. When y equals x to the power of 3, the graph takes this form, passes through the origin here. Have them in your memory, you see. So now let's see what we actually mean by transformation. It's best to look at a graph and then we'll be able to explain better. Transformation of graphs or functions, it simply means you are given a function of a graph and then they ask you to do something to that graph, whether to translate this graph on the x-axis, or you translate it on the y-axis, or you stretch the graph, or you shrink it. That's what we mean by graph transformations. And the basic transformations we have y equals f of x plus a. If the function is given to you in this format, where a is a constant, and this represents a translation on the x-axis. Translation on x-axis. But this translation here is a negative translation. Because it is positive inside this parenthesis, it means this number here is negative. Yeah? If it was negative here, it means this a is a positive number. That's what you have. If you have y equals f of x plus a, This is a translation on y-axis of A. It's positive, here is positive. Negative, negative. It's only this one that changes sign on the x-axis. Is inside the brackets. And we'll have another one. Y equals A f of x. This one represents a stretch. A stretch by a factor of A. Stretch, let me just say stretch on the y-axis by a factor of A on the y-axis. Positive, it's positive. And if you have y equals f of what is that? That is a stretch by a scale factor of A on the x-axis. And finally, you have y minus f of x. This is a reflection. REF, reflection. On the x-axis. So these are the basic transformations we have. They can give you a problem. They might combine all of these together, or they might just give you a problem that will just use two of these transformations. So for example, we look at this graph. This is x, this is y, and this graph is y equals f of x. That is the graph y equals f of x. If you are now given y equals f of x minus 2, from this original graph, you are now asked to plot this graph. You are asked now to sketch this graph. You are given this y equals f of x. This is the graph that represents this function. But now this function, I've made some changes here. Y equals f of x minus 2. And they now ask you to sketch this graph with reference from this one. This is what we have just explained here in the translation. So what are we looking at? We are looking at this first one here. Translation on the x-axis. Because it's negative here, so inside, because it's negative inside, so we have it to be positive outside. So now, to sketch this graph with reference to this one, you can have something like this. It was 0 here. Yeah? So now it's moving on the positive x direction plus 2 units. So 1, 2, 1, 2. So this 0 here is now here. It's moving 2 units. So your graph will now look, this is your vertex. So your vertex will now be here. So your graph will now look like this. Sorry, my drawing might not be appropriate. It should be a smooth curve. It's going to be something like this. Y, X. You've transformed this graph, y equals f of x, to y equals f of x minus 2. So we've done this one. So now, they ask you to transform this same graph into y equals f of x minus 2 plus 1. So what have we got here? We translated this graph to this form, and now we are given a 1 here. So it means now we are translating, we are looking at this one, this graph on the y-axis. When it's plus, it's plus. On the y-axis, the sign is the same. It doesn't affect the sign. If it is minus, it's going to be minus. If it is plus, it's going to be plus. So what do we do next? We know this graph is already here, 2, but it's going up by 1. So it was x, we know y is 0 here, but now we are given y to be 1. So this graph now, the vertex will be here. This is 1. This is 2, 0, 2. X is 2, y is 0. So now your vertex will be here. This is your turning point. So your graph will look like something like this. So this is the graph y equals f of x minus 2 plus 1. This is what we mean by transformation. I hope you like this video. Thank you.